Hello everyone. So next we're calculating the pH of a strong acid and a weak base. So we're going to calculate the initial pH. So for this question we have to calculate. Hello everyone. So the next question we have is that we have to calculate the initial pH, and this is the initial pH of a strong acid and a weak base. So the question states calculate the pH of 25 milliliters of 0.1 molar NH3, which is a weak base, titrated with 0.1 molar of HCl, which is a strong acid. So I've written out our equation, and I've looked up the Ka and the Kb values. So in terms of concentration of our NH3, we have 0.1 molar and 0 for NH4 plus and 0 for OH minus. For the change, you're going to lose 1 mole, so minus x plus x on the other side because you're getting the product, so you have 0.1 minus x plus x plus x. Since you have OH minus, this means that you are going to use the Kb value. So Kb equals x squared, because this is your products, over 0.1 minus x. Ignoring the change, you're going to get 1.79 times 10 to the negative 5 equals x squared over 0.1. When you solve, you're going to get 1.34 times 10 to the negative 3. Plugging this into the POH equation, so POH equals negative log OH minus. You're going to get POH equals 2.87, or pH equals 11.13. So next, we're calculating the pH after adding 10 milliliters of acid. So this means that we have 0.01 molar of acid times 0.01 liters of the acid, so that's 10 milliliters. This gives us 0.001 moles of our acid, of our H+. Great. We already know that we have 0.0025 moles of NH3. This means that when you add it together, you're going to neutralize, and you're going to make 0.001 moles of NH4+, and remaining, this means you have 0.0015 moles of NH3 remaining because 0.001 was neutralized and it made the conjugate NH4+. So keep in mind that the total volume, it changed now, because before we had just 25 milliliters, but now we added 10 milliliters of acid, so in total we have 35 milliliters. Using our ice table, now let's fill this out and try to calculate our new concentration. So NH3, we have 0.015 mole of NH3 divided by 0.035 liters. I'm showing the micro calculations here for initial, but you can actually solve this ahead of time and just plug in the final concentration instead of breaking this down. But I'm breaking this down just so I know that I have incorporated the new volume change. And for NH4+, we solved that earlier, so that's 0.01 mole of NH4+ over 0.035 liters. OH minus is 0, so for the change, it's going to be minus x plus x plus x. And then for the equilibrium, if you solve that, you're going to get 0.043 minus x, 0.029 plus x, and positive x. So once again, we're going to solve using Kb because there's OH minus here. So by doing so, you're going to get 1.8 times 10 to the negative 5 equals 0.029 plus x times x over 0.043 minus x. You can ignore the change, and this means you're going to get 1.8 times 10 to the negative 5 equals 0.029x, and on the bottom 0.043. When you solve, you're going to get x equals 2.67 times 10 to the negative 5. Plugging this into pOH, you're going to get pOH equals 4.57. And using the pH formula, you're going to get pH equals 9.42. Next, we are going to calculate the pH at equivalence point. This means that the moles of acid and the moles of base are equal. So this means that the remaining moles of NH3 are going to be 0 because they would have neutralized. So moles of NH4 is going to be 0.0025 moles. And our total volume now has to be 50 milliliters because we've added another 25 milliliters. So we have 0.05 liters. NH3, there's nothing initially, and H plus nothing initially. Change is going to be minus x plus x plus x. And when you solve, you'll get 0.05 minus x, and here equilibrium plus x and plus x. So you have to use a Ka value because you have H plus in your equation. So this is going to be 5.56 times 10 to the negative 10 equals x squared over 0.05 minus x. Ignore the change on the bottom. When you solve, you're going to get x equals 5.27 times 10 to the negative 6. With this, you can find the pH. So pH is going to be 5.28. And I got this because you use pH equals negative log concentration of H plus. Plug it in and you get 5.28. Next, we're going to solve pH after adding 35 milliliters of acid. So this means that for acid, we're going to have 0.0035 moles. This will react with the base. And earlier for the base, there was 0.025 moles of the base. This means that the H plus remaining after that is going to be 0.001 moles of acid remaining. So from here, we can calculate for the pH, but first we need to recognize the volume. And volume would be the 25 milliliters of base initially. Now you're adding 35 milliliters of acid, so now you have 60 milliliters. So from here, concentration of H plus is going to be 0.001 moles over 60 milliliters. So this would be 0.06 liters. This would give you 0.01667 molar, and pH would be negative log H plus, and plugging this in, you're going to get pH of 1.78.